This video will review the adjustment of the cup and cone bicycle hub. In a cup and cone hub, ball bearings are trapped between a cone-shaped bearing race threaded to the axle and a cup-shaped bearing race pressed into the shell. Adjustments are made by turning the cone along a threaded axle. Here we have a wrench fitting on the cone and above it a lock nut. This is a cup and cone hub. However, this one has no wrench flats. It is likely a cartridge bearing hub. Bearings simply wear out, they're disposed and replaced. There is no adjustment. These are some examples of hubs with wrench flats, and they're likely cup and cone hubs, which are adjustable. On this through axle, we can see the lock nut and below it, the cone. A bearing adjustment should result in the loosest possible setting of the hub, but without knocking or play when the hub is mounted for use. It may or may not feel smooth to your finger even at this correct setting. Remember, the wheel is rotating around the axle and has a lot more leverage than your fingers. The smoothness you feel is subjective, and it's going to depend upon the quality of the hub and the wear it has seen. The adjustment procedures will vary slightly depending on the type of hub and axle. The 10 and 9 millimeter hollow axles tend to flex slightly when closed in the bike with a quick release skewer, because the skewer tends to add a little bit of preload to the bearing. We need to account for that with the adjustment when it's outside the bike. However, if it's a solid axle or a through axle, they don't do that so much. These, the adjustment outside the bike and inside the bike, effectively the same. Understand as well that bearing adjustments can be finicky. It's especially true if you're working without an axle vise. Lastly, remember to check for play only when the lock nut is tight against the cone. It's natural for these two pieces to have play against the external threads of the axle. It only goes away when the two are tightened against one another. An important difference between a hub overhaul and a hub adjustment is that in the overhaul, we'll know if there's pitting and wear on the inside. On a hub adjustment, that may show up through the lack of a good adjustment. But in any case, before you remove the wheel, test for bearing play. We grab the frame, we grab the wheel, pull it side to side, 90 degrees from the plane of rotation, checking for play, and check in several positions. There's no play here. Now, pull the wheel out, and again, check for play out of the bike. Grab moving the axle, not the skewer, the axle one side down, one side up, back and forth. If you feel play here, out of the bike, on a quick release hollow axle, and in the bike there was no play, it's adjusted. This one's done. To continue the adjustment procedure, remove the quick release skewer. With the skewer out of the way, we can now rotate the axle and feel for any pitting or possible other issues internally. Also see if you can detect an oscillating axle. This axle is oscillating and is bent. It will require a new axle before it can be properly adjusted. Hubs are typically adjusted from only one side. On a rear wheel, the non-drive side is the adjustable side. Drive side is assumed to be fixed. On a front wheel, with a rotor, the non-rotor side is the adjustable side. An axle vise like the AV1 or AV5 can really speed the work as it holds the axle when we make our adjustment. Take the fixed side of the hub and mount it down in the axle vise and secure. In this case, The cones are underneath that lock nut for the rotor. The rotor has got to get out of the way. This is a hollow axle that's susceptible to flex when loaded in the bike, a little bit of preload from the skewer. So because of that, we're going to purposely start our adjustment too tight, then back up into play. So first, we're going to find the cone and hold it with the correct cone wrench. We're going to loosen lock nut. With the lock nut loose, we're going to find the point that that cone, when tightened, just hits the bearings. We can feel it very gently here, right there. We're contacting something. That's the ball bearings. From this point, we're going to hold and secure the top nut. This is going to be purposely too tight. This is a very good place to use a torque wrench to learn muscle memory. We're going to set it for 10 Newton meters. I was close to it. To learn that, take a wrench, hold the cone, put a wrench on top, and note the angle that you have. Hold the cone. I'm going to back up and then come at that same angle. That is 10 Newton meters. You'll be doing that a lot with the hub adjustment. So it's good, again, for muscle memory. There should be no play here, but check it anyway. No play. So now we're going to start backing up small amounts. Hold the cone, loosen the lock nut. Going to back up. This would be a quarter turn. That would be an 1/8 of a turn. We want to come back about a 1/16 of a turn. Hold and secure. And again, check for play, pulling up and down. No play. Adjusting without an axle vise can be done, but it also can prove frustrating at times. So here, I need a little bit of play. I have no play at all. It's a quick release style. I need that little bit of play. I'm going to hold the cone with the cone wrench. I'll come onto the lock nut, break it free. Now, I just simply can't turn the wrench counterclockwise. The whole axle tends to turn. If I tighten, I've gained nothing. I haven't changed anything. The cone needs to move relative to the axle. So here, I can reach through, hold the other side. I want to back off a little bit. There we go. It backed off without the cone moving. And now I'm ready to tighten the lock nut again. Then that axle moved just a little bit. So that's the frustrating part. It's hard to keep it consistent. I overshot for sure. This is play, quite a bit of play. I need to break it free, turn the axle and the cone relative to each other, lock it up again. Try one more time, looking for that little bit of play. That's why an axle vise is nice. Repeat until we find just a little bit of play. Back 1/16 of a turn, hold, secure. Still no play. Hold the cone wrench from moving. Now we can adjust it that slight amount and re-secure. Now a slight amount of play. A little bit tighter, we had no play. This is the first indication of a little bit of play. Time to test it in the bike. We need the dropouts of a bike to test our adjustment. We don't even need the chain hooked up, and we don't even need the rotor in place. What we do need is a proper, tight, quick release skewer. Here we set it. We have resistance about halfway through the swing. It's fully closed. Grab the wheel Checking for play, pulling the wheel side to side. There is no knocking. We had some play out of the bike, no play when loaded in the bike. The hub adjustment is good. However, the user needs to understand that a proper and tight skewer is part of the bearing adjustment. The wheel can come out, change goes back on, the rotor goes back on, back in, consistent skewer closing, ready to ride. The solid axle hubs and the through axle hubs that are cup and cone adjustable type share the same procedure. We want them as loose as possible with no play. So because of that, we're going to purposely begin with play and creep along incrementally until play just disappears. So especially in the through axle, the AV5 is a good one to use. With our larger jaw openings, it's easy to hold the fixed side secure. So from here, we're going to hold the cone, put a wrench on the lock nut, hold the cone, break free of the lock nut. We're going to again find that contact, that gentle contact, it's right there. The cone is hitting the bearings right there. This time we are going to back up 90 degrees. Hold the cone, secure that lock nut, and check for play. Grab the axle, grab the rim, back and forth. Absolutely, we have play. This is too loose. We're now going to creep a little at a time, down, down, down with the cone until play just goes away. Break free of the lock nut. So again, that 16th of a turn, stop. And we're going to secure. And now test. Less play for certain, but there absolutely is some knocking. Still too loose. Now, hold the cone. Break free of the lock nut. So our small clockwise turn. Hold, secure, test again. Play is gone. We had play a little bit looser. Cone was backed away from the ball bearings. This would be the loosest setting without play. That's what we can expect out of this hub. It doesn't need to be tested. Again, through axles tend not to have that compression. If you're unable to find an adjustment between what you feel is too tight and too loose, there could be some internal issues inside the hub. One is pitted and worn bearing surfaces. There's no fixing that. It simply means time to replace parts. Axles cannot be successfully rebent to being straight. Replace the parts as needed. If a hub does not seem to hold its adjustment, there may be a problem with the security of the lock nut to the cone. You may have been working on the adjustable side, but did you check the security of the fixed side? For this hub, we can see the drive side lock nut is finger tight. This is not appropriate, as it means play will occur between the cone and the threads of the axle. It gives you a false sense of bearing play. The side needs to be tightened. However, to do this, we must hold the cone below the lock nut, and that is below all of these gears. These need to come off. To tighten the lock nut, I must hold the cone, but I can't get to it because it's down inside. We must drag this axle up. To do that, I need to come to this side, find the cone, remove the lock nut, Remove the spacer. Back the cone up nearly to the end of the axle, which will allow access now to the cone. Holding the cone, the fixed side can now become truly fixed. Back in, back over, run this down again. Spacer, same orientation as before. We can now adjust from the adjustable side because we know the fixed side is properly tight. Proceed with the adjustment as before. Thanks for joining us, and mind the knocking in the hub.